All right, today we're pulling back the curtain on Ethereum. We're going to demystify everything from its super confusing transaction fees all the way to the massive upgrades that are completely changing the game for its future. So let's just dive right in.
So, you've probably been there, right? You're trying to do something on Ethereum and you're just staring at your screen at this mess of terms. Base fee, priority fee, max fee, and you're thinking, what is going on? What am I even paying for, and why does it have to be this complicated?
Well, trust me, you are definitely not alone. It's a beast of a system, for sure. But it's also pretty fascinating once you see how it works. To really get a handle on the cost, we've got to pop the hood and take a look at the engine that makes the whole thing run. Okay, so our first stop is the fee market. This whole system got a big overhaul with an upgrade called EIP 1559. The easiest way to think about it is like paying tolls to use the Ethereum highway, and that toll is made up of a few different parts. First up is the base fee. This is kind of like the non-negotiable price of admission to get on the highway. Now, the really interesting part is you don't set this price. The network itself calculates it automatically based on how much traffic there is. If the last block of transactions was jammed, the base fee goes up. If it was empty, it goes down. And here's the kicker. This part of your fee gets burned. Poof, gone from circulation forever. Next, we've got the priority fee. And this is exactly what it sounds like. It's a tip. You add this little extra to basically bribe the network validators, the computers running the whole show, to pick your transaction out of the crowd and process it faster. When things get busy, a good tip can mean the difference between getting through now or waiting for hours. And finally, there's the max fee. Just think of this as your safety net. It's you telling the network, hey, I'm willing to pay up to this much in total, but not a penny more. This protects you from getting hit with a crazy bill if the base fee suddenly skyrockets. You'll almost always pay less than your max, but it's there just in case. Okay, let's see this in action during a major traffic jam. So let's say you set your max fee at 202 gwei. When you send your transaction, the base fee is just 100. No problem. But, look what happens. The network gets totally slammed, and every new block is 100% full. You can see that base fee just marching relentlessly upwards, block by block. By the time we get to block 7, the minimum toll to get on the highway has jumped over 202. And since your max offer is now below the minimum price, your transaction is stuck on the side of the road, ineligible. So we can see that fees are constantly changing with network traffic. We get it. But what is the actual machine that's doing all the work here? For that, we need to go one layer deeper, inside what people call the world computer, the Ethereum virtual machine. The EVM, well, it really is the heart of Ethereum. It's not just one computer in a server room somewhere. It's this single shared computer that's actually made up of thousands of machines running all over the globe. Its entire job is to execute smart contracts, which is just the code, and update the balance of every single account on the network after each transaction. Now, the easiest way to wrap your head around this is to just think of a regular computer. The EVM has 3 key parts. First, the stack, which is like a scratch pad for doing quick math. Then you've got memory, which is like your computer's RAM. It holds data for a little while, just during a transaction, and then it's wiped clean. And finally, you have storage. That's the permanent hard drive. That's where account balances and all the important stuff gets written into the blockchain's history, forever. And this brings us right to the big problem, this central conflict of the whole Ethereum story. We have this unbelievably powerful world computer, but just like our highway, it has a massive, massive traffic problem. I mean, really think about that for a second. Every single thing that happens on Ethereum, from sending a friend a few bucks to trading a complex financial asset, has to be processed in order by this one shared machine. So what do you think happens when millions of people all try to use it at the same time? You guessed it, total gridlock. The highway becomes a parking lot, and the tolls, those gas fees we talked about, they go through the roof. This is the fundamental problem that Ethereum developers have been trying to solve for years. It's called the scalability trilemma, this constant fight between being fast, being secure, and being decentralized. How do you get more of one without giving up the others? Well, here's the good news. The solution is no longer some distant dream. A huge series of upgrades is finally here, laying out the blueprint to turn that single-lane dirt road into a massive multi-lane superhighway. And the goal here is, honestly, it's pretty mind-blowing. We're talking about scaling Ethereum to handle over 100,000 transactions every single second. To put that into perspective, right now on its main layer, it handles maybe 15. This is a colossal leap. Yeah, I know what you're thinking. How on earth is that even possible? It sounds like pure science fiction, going from 15 to 100,000. The answer lies in a landmark upgrade, codenamed Fusaka. And the genius of it is that instead of trying to make the main computer itself faster, it completely revolutionizes how the network handles data. Because data has always been the real bottleneck. It all comes down to this really clever piece of tech called Peer Data Availability Sampling, or PeerDAS. And here's where the magic happens. Before, every computer on the network had to download all the data for every transaction. It was exhausting and slow. Now, they just have to grab a few tiny random pieces. And through some really smart math, just by checking those little samples, they can be 100% sure the entire thing is there and it's all correct. This book analogy just nails it. The old way? Imagine you and 100 friends need to check if a book is complete. Every single one of you has to read the entire 1,000-page book, cover to cover. What a colossal waste of time. The new PeerDAS way? You just read one random sentence from page 50, your friend reads one from page 800, and so on. By just sharing your tiny little pieces, you can all instantly confirm the whole book is there. It's a total game changer. Okay, so the tech is seriously cool. But let's be real, who cares about the tech if it doesn't do anything for us? What does this actually mean for you, the person trying to use this stuff? What's the payoff? Well, the most immediate and awesome impact is on what are called Layer 2 networks, those express lanes built on top of Ethereum. Before the Fusaka upgrade, a typical transaction on a Layer 2 might have cost you about 10 cents. After, with all this new super cheap data space available, that same transaction now costs less than a single penny. We're talking about a price drop of over 90%. That's huge. And look, this isn't just about making the things we already do a little bit cheaper. When you slash the cost of something this fundamental, this digital space, it's like discovering a new continent. It opens the door for brand new ideas and applications that were just flat out impossible before, because they would have been way too expensive to even dream of running. So, in a pretty short time, we've gone from this clogged up digital highway to what feels like a vast, open digital frontier. And that just leaves us with one last, really exciting question. With a foundation this powerful and this cheap to use, what on earth is going to be built next? And as always, just a quick reminder that this content is for informational purposes only and should definitely not be taken as investment advice. Thanks for diving deep with us today.